Okay, so this is still technically section 13.3 in our book, and now we're going to discuss the unit circle. And this is a big idea in our big fundamental idea in trig, and we use this to solve a lot of these problems that we'll work with, and graphing, and doing a lot of other things. So what we're going to be able to do is we're going to use our special triangle values, the 30s, 60, 90s, and 45, 45, 90s, to find angles that are a part of a circle. Okay, we've already kind of done this. Okay, so what I'd like for you guys to do is, using your calculator, so if you follow along with the screen, we want to find the exact coordinate of a point located at the intersection of a unit circle. Unit circle, biggest idea here, unit circle, all it is a circle with a radius of 1. And what I want you to find is, so if we draw a circle here, and we know, so for example, just right here, the radius is going to be 1. And what I'd like for you to do is, without using your calculator, because that's what the second spot is, I want you to think about the points that are located at the, I want you to do 0 also. So I want you to find the points that are located around this circle at the 0, the 90, the 180, 270, and technically 0 is the same as 360. We're back where we started. So before you use your calculator, I'm going to go ahead and pause the video, give you a couple minutes, and go ahead and think about what those values are. You pause it yourself and then, hit play and check with your calculator, and then come back to the video. Okay, so hopefully you said to yourself, well, the distance from the radius, or excuse me, the center to the edge is 1. So I know all of these values are 1 right here. So this coordinate at 0 degrees is going to be 1, 0. I know this guy is 0 because I didn't move up or down, and that's what y does. So if I look at the 90 degrees, I'm going to have that same type of mentality. I'm going to go ahead and, okay, I didn't move left or right, so my x value is 0, and I moved up 1. For the 180 degrees, because we're in a coordinate system, I moved left 1 and I didn't move up or down. So that's the point at 180. The point at 270 is I didn't move left or right, so that's a 0 value for x, but I moved down 1, so that's a -1. And so when we find sine and cosine and tangent of all of these previous values, if I find sine of 0 degrees, that's going to give me 0. If I find cosine of 0 degrees, that's going to give me 1. So what other conclusion can we make out of what is sine and what is cosine? When we're dealing with the unit circle, sine is going to be our y value, and cosine is going to be our x value. And so if I did the same thing with 90 degrees, sine of 90 would give me 1. Cosine of 90 degrees would give me 0. This is our y value, this is our x value. And so what the conclusion is that we can make is that, in general, we can state that sine is going to equal x, sine is going to equal y, and cosine is going to be our x value. So if I said cosine is 60 degrees, whatever that value is, that's the x value in the triangle. Okay? And that's how we can use the unit circle in connection with our coordinate system. And the unit circle, it's a circle, we've worked with them, it's just that the radius is equal to 1. We'll do some more examples with this idea in subsequent videos, but we're at about 4 minutes here, so I wanted to cut it off and kind of go into some more problems. And when we're dealing with the unit circle, this is all no calculator stuff. Even though we're using our calculator to confirm the answers and kind of discover what we're getting, when you take your test, these types of problems are no calculator problems.